Before we get started, we would like to introduce ourselves. We are students from 11 STEMB and we will tell you some small but handy information that you will need when you reach or start your pre-calculus. So now, let's get started. The basic concept of conics. So here, before we start digging deep, we all need to know first what really is conics. What is conics? A conic section, also called conic in geometry, any curve produced by the intersection of a plane and a right circular cone, depending on the angle of the plane related to the cone. The intersection is a circle, an ellipse, and hyperbola or a parabola, and those four mentioned in the current slide is what you call conic section.
Now, you might be wondering, what is conic sections? What does the conic section look like? A cone and conic sections, the napes and the four conic section, each conic is determined by the angle the plane makes with the axis of the cone. Conic sections are obtained by the intersection of the surface of a cone with a plane and the certain features. We'll also talk about the conic section and its properties. Parabolas are U-shaped graphs that open either upward or downward. Ellipses are oval in shape with the circle as a special ellipse, where the distance vertically and horizontally from the center are equal. Hyperbolas are graphs with always come in pairs. These parabola-like graphs either open vertically or horizontally. Key points. A conic section, or simply conic, is a curve obtained as the intersection of the surface of a cone with a plane. The three types are parabolas, ellipses, and hyperbolas, which was mentioned in the previous slide. Conic section can be graphed in a coordinated plane. Every conic section has a certain features, including at least one focus and directrix. Parabolas have one focus and directrix, while ellipses and hyperbolas have two of each. A conic section is a set of points P whose distance to the focus is a constant multiple of the distance from P to the directrix of conic.
Key terms for conic. Number 1 is vertex, extreme point on a conic section. Top is asymptote, straight line which a curve approaches arbitrarily closely as it goes to infinity. Next up is locus. It is the set of all points whose coordinates satisfy a given equation or condition. Next is focus. It is a point used to construct and define a conic section at which rays reflected from the curve converge. 5 is nape, one half of a double cone. Number 6 is conic section, any curve formed by the intersection of a plane with a cone of two napes. Last but not the least is directrix. It is a line used to construct and define a conic section. A parabola has one directrix. Ellipses and hyperbolas have two. The common parts of conic sections. While each type of conic section looks very different, they have some features in common. For example, each type has at least one focus and one directrix. A focus is the point about which the conic section is constructed. In other words, it is a point about which rays reflected from the curve converge. Number 3 is a directrix is a line used to construct and define a conic section. The distance of a directrix from a point on the conic section has a constant ratio of the distance from that point of the focus. These properties that the conic sections share are often presented as the following definition, which will be developed further in the following section. A conic section is the locus of points P, whose distance to the focus is a constant multiple of the distance from P to the directrix of the conic. These distances are displayed as orange lines for each conic section in the following diagram.
Parts of the conic sections. The three conic sections with focus and directrix labeled. Parabola. A parabola is a set of all points whose distance from a fixed point, called the focus, is equal to the distance from a fixed line, called the directrix. The point halfway between the focus and the directrix is called the vertex of the parabola. Number 2. In the next figure, four parabolas are graphed as they appear on the coordinate plane. They may open up, down, to the left, or to the right.
For parabolas opening in various directions, the vertex lies at the midpoint between the directrix and the focus. Next is the ellipses. An ellipse is the set of all points for which the sum of the distances from two fixed points to focus is constant. In the case of an ellipse, there are two focus and two directrices. In the next figure, a typical ellipse is graphed as it appears on the coordinate plane. The covertex, semi-minor axis, the vertex, focus, center, linear eccentricity, and the semi-major axis. Ellipse, the sum of the distances from any point on the ellipse to the focus is constant. Hyperbolas. A hyperbola is the set of all points where the difference between their distances from two fixed points, the focus is constant. In the case of a hyperbola, there are two focus and two directrices. Hyperbolas also have two asymptotes. A graph of a typical hyperbola appears in the next figure. Hyperbola. The difference of the distances from any point on the ellipse to the focus is constant. The transverse axis is also called the major axis, and the conjugate axis is also called the minor axis. Applications of conic sections. Conic sections are used in many fields of study, particularly to describe shapes. For example, they are used in astronomy to describe the shapes of the orbits of objects in space. Two massive objects in space that interact according to Newton's law of universal gravitation can move in orbits that are in the shape of conic sections. They could follow ellipses, parabolas, or hyperbolas depending on their properties.
That's all. Thank you for listening.